Hi everybody, me again. Let's look at equations with variables on each side. Let's look at a fractional example. In other words, an example that uses fractions. And I just want to apologize if there's some background noise going on here. That's the way it is. I'm doing this while the pandemic's going on, and so we've got a bunch of people in the same house, and that's the way it is. So let's look at an example using fractions. All right. So the example we are going to use, and I didn't have this typed up because they're really messy to type up, and I'm going to do this in white, is we have negative 5/4 c minus 1/2 equals negative 3/4 plus 5/8 c. All right, so first thing we got to figure out here is we're gonna draw our fence. We're gonna go ahead and we're gonna try. First thing I always try to tell you guys to think about is what side should we put the variables on. Don't worry about anything else. Always start with worrying about the variables and take care of those first. So if we look at that, basically all you have to do is you have to decide which number is bigger, negative 5/4 c or positive 5/8 c. Those are my variables. My variables, and we'll use yellow for the variables again. So we've got negative 5/4 c, and we've got positive 5/8 c. Well, you don't even need to look at the numbers. You just look at the signs because they're different. And positive is always larger than negative. So that means that we are going to move this over to the other side. Because like I said, we always move the smaller amount over to the side with the larger amount. So we do that by adding 5/4 c to both sides. And I'm going to write this out just the way I would if it were a normal integer, which it's not. So now, well, we have a problem here. We have 5/8, and I'm gonna do this on the next sheet of paper here. We have 5/8 plus 5/4. So when we do this problem, all right, what we got to remember is when you're adding fractions, you need this number. In other words, you need the denominator to be the same. So in a case like this, you're looking for something known as the common denominator, right? So this should all be reviewed for you. And generally speaking, it is the smallest number that both numbers can go into. Well, look at this. You've got 8 and 4. Well, 8 can't go into 4 because it's too big. But 4 can go into 8. And then you think about, okay, if I were going to write this as a fraction over 8, what do I have to do to the 4 to make it 8? Well, you would have to multiply it by 2, right? You'd have to multiply it by 2. And that means we got to do the same thing. And actually, I'm going to rewrite this. I'm going to get rid of some of the circling here, right? So I'm going to go times 2. And because I'm doing it on the denominator, you have to do the same thing in the numerator to keep it equal, all right? It's kind of like solving equations. And then the 5/8 can stay how it is, and you'll see why in a second. Because we've got 5/8 now, and then we got plus, and then 5 times 2 is 10, and then 4 times 2 is 8. So these are now both the same. So I can add this up, and it's all going to be over 8, all right? And then you just add the numerators together, 5 plus 10, all right? Then this becomes 15/8. And we're going to leave it like that. And the reason we're going to leave it like that is because we're using it in an algebraic problem. And it's a lot easier to work with something like this than it is with something like 1 7/8. All right, so we're going to leave it in improper fraction form. And I would recommend that as often as possible when you do algebraic problems to leave it in improper fraction form. Okay, so we've decided that that's 15/8. So let's go back to our example here. All right, and so we've determined that this gives us 15/8 c, right? And then we'll finish writing this out. Okay, so that's equal to negative 3/4. Wow, freaking out here. Negative 3/4 plus 15/8 c, and then you've got your negative 1/2 over here because these canceled out. All right, now I got to move this over to the other side because I've got my cows over here, and then we've got a bunch of chickens over here, and those they got to go. So you do the opposite. So we're going to add 3/4 to both sides. So I'm going to go plus 3/4 here, We're going to go plus 3/4 here. And then we're going to 1/2 plus 3/4. So I'm going to do that over here because this isn't quite as ugly. If you have 3/4 and you're subtracting 1/2 from it, think about what's another way of writing 1/2. Well, another way of writing 1/2 is 2/4, right? You decide you're going to multiply both by 2, right? And that would give you 2/4. So you wind up with 3/4 minus 2/4, which gives you 1/4. So now what I'm left with, all right, this is starting to kind of simplify nicely. All right, now what I'm left with is 15/8 C equals 1/4. So my last step is I've got to get rid of this fraction. And do you remember how to do that? Well, what we do is we always multiply it by the reciprocal of whatever the coefficient is. So the coefficient is positive 15/8, so the reciprocal would be 8/15. So whatever you multiply by one side, you multiply the other side by. Okay? And then it's just a matter of realizing that these cancel, so you get C is equal to, I'm going to finish writing this. Well, 8 times 1 is 8, and then 15 times 4 is 60, and I can simplify that. I can divide them both by 4. All right, so C, 4 goes into 8. Let's see, let's write this, divide by 4, divide by 4. 4 goes into 8 2 times, 4 goes into 60 15 times. And your answer is 2/15. And if you went through and you plugged this in to all this, you would get the same answer. It's this is an ugly problem. There's a lot going on, but if you can just basically remember your common denominators and how you find those, and then just chunk it out the way I've been trying to teach you how to do this, you should be completely okay on this.